welcome back. Hopefully you've got an idea for your project already. So this video is going to help you start figuring out what you're going to do with your data. And we are going to start by talking about measures of what they call central tendency. So if we have a data set, how can we measure where the middle is? There's actually more than one way to do that. And you've probably heard of these statistics in the past. We're going to bring them back. We're going to be using this data set for our discussion today. And this data set was obtained a couple years ago. In more traditional semesters, one of the first days of school, I give everyone a survey to do. And I gather data on lots of different variables from my statistics classes. And one of the many variables I ask for is the number of texts that you received yesterday. And before the proliferation of smartphones, texting was the main form of communication, and it's still there. Now there might be more going on in like Instagram and Twitter and all that stuff. So I just said, how many times do you get something from someone else on the internet per day on average? And these were a few of the responses. I have concerns about this person. that's 8,000. Maybe they meant to put 80.00. Who knows, right? 8,000 is a lot. You would be attached to your phone. Maybe they were. I don't know. But we're going to use this data set and we're going to try and figure out where the middle of this data set is. And no matter what we use to try and find the middle, a good first step is going to be to take this data set and put the numbers in order from least to greatest. So I'm going to put myself on the spot. I actually haven't done this yet. We're going to calculate, or we're not going to calculate anything. We're just going to put these in order. I think 10 is the smallest, and there are 2 of them. And then 15, you're doing this in your notes too, right? Let's race. 60 is here twice. 65, 80, 200, and then the 8,000. Ha! Did I win? You didn't pause the video, did you? Because that would be cheating. You big cheater. Maybe. I'm watching you. Okay, so if we want to find the middle of the data set, the first step, no matter how you calculate it, is going to be to put the data in order from smallest to largest. So let's start talking about different statistics that we can calculate to suggest where the center of this data set is. The first one is going to be the mode. The mode. This is the least sexy measure of center. It's not really used all that often, and you're about to see why. You might know what the mode of a data set is. Well, what's the mode of this data set? Well, maybe first we should establish what the mode is. That actually differs. The definition of what the mode is for a data set differs depending on who you ask. Reasonable statisticians can differ one way or the other. I'm going to go with our textbook's definition of the mode for this, and it might be different than what you think. Their definition is the mode is the data value that occurs the most often in a data set. It's the data value that occurs the most often. The numbers 10 and 60 both appear twice in this data set. Does that make them both the mode? Are there 2 modes? Well, if you read this definition carefully, there can't be 2 modes. It is the data value that occurs the most often. Is there a data value that occurs the most often here? No, there's a tie. So what's the mode? This data set doesn't have one. If there isn't a single mode, there is no mode. As long as you're in this class this semester, this is the rule for mode. Either there's one or there aren't any. If you tell me there are multiple modes to a data set, I'll know you didn't watch this video, and I don't know what I'm going to do with that information, but it's probably not good for either of us. So, either there's one mode or there isn't one at all. And maybe if you take a college statistics course or if you take AP statistics, this definition might change. But based on the textbook we're using, that's the rule. All right, so calculating the mode, very easy. However, the data values that occur the most often were 10 and 60. 10 was one of those numbers. Is this anywhere close to the middle of this data set? No. And actually, for many data sets, the mode is going to be a number closer to one of the ends than the middle. So if we're trying to find the best statistic of the middle of a data set, the mode ain't where it's at. Sometimes it's going to be okay, but chances are one of the other statistics we're going to be calculating in this video is going to do at least as good a job as the mode, if not a better job. So, bye mode, you kind of suck. Let's move on, shall we? To a measure that actually can do some good. Let's move on to discussing the median. The median. Again, if you want to calculate the median of a data set, the first step would be put your data in order from smallest to largest. That's the case for all of these statistics. Now, I've been teaching this class, this is my third year, and I've had students tell me, Mr. C, we learned how to calculate the median of a data set years ago. Here's how it works. You take the numbers at the ends and you cross them off. And then you take the numbers that are closest to the ends that are now on the ends, cross them off. Keep crossing pairs of numbers off until you get to the one in the middle. Simple, the one that's left is the median. And to that I say, okay, I suppose that could work. But it turns out the people who use that method are the ones most likely to get the wrong answer. How do they mess it up? I have no idea. But the people who use that method are the most likely to get the wrong answer for the median of a data set. So I'm not going to tell you to do it that way. If you want to, you're playing with fire. I'm just saying, right? Here is how you calculate the median of a data set accurately. You have to know how many data values are in the data set. So how many values do we have? We're looking at just the one in green because that's the one in order. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of values in the data set we're going to denote as n. Okay, so we're going to call that the sample size. So our sample size here is 9. To calculate the median, you're going to take this calculation. You're going to take n, add 1 to it, and divide by 2. Why are we doing this? You'll see in just a second. So if n is 9, this is going to be 9 plus 1 over 2. That's 10 over 2, which is 5. Is this some kind of magic trick? Is 5 the median of this data set? Of course not, no. Of course not. What this tells you is which data value is the median in order. So what this is saying is for a data set of 9 values, the median is the 5th one as long as the data set's in order, from either smallest to largest or largest to smallest I recommend smallest to largest. It's the fifth number. So you just count 1, 2, 3, 4, 5. Booyah! That's 60. Fifth value is 60. So the median is 60. Is that more difficult than crossing off numbers? I guess, if you really just can't process how this works. But I think this is pretty simple in terms of formulas. And this just tells you how to count to the middle. And that's it. It's more complicated, isn't it? No. As long as n is an odd number, this will be a whole number, and it will tell you which value it is. But what happens if this is an even number? So let's just say for now that we know what the median of this data set is, let's take off one of the 10s. And now let's calculate the median of this data set. Okay. We're still going to use this. So n plus 1 over 2. We're still finding the median here. The median of our new data set that has one of the 10s gone. N plus 1 over 2. N is now 8. Right, because we took one of the values out, there are 8 left. So if n is 8, this is 8 plus 1 over 2, which is 9 over 2. That's 4.5. And I do recommend turning this fraction into this decimal, this mixed number here. Well, it's not a mixed number, really. That would be 4.5. I recommend turning it into 4.5. Okay. And the reason that I recommend writing it this way instead of leaving it as 9 over 2, the median now is the 4.5 value in the data set. What? What's the 4.5 value mean? Okay. If your n is even, this calculation is going to give you something 0.5 every time. What that means is you need to take the average of the 4th and 5th values. You just need to take the 4th and 5th values, the two numbers, the two integers closest to this, and average them together. Okay, so we take the 4th and 5th values, that's going to be 60 and 65. And taking an average just means we add those two numbers together and divide by 2. We're finding the number that's halfway in between. That's going to be 125 over 2, which is 62.5. All right? So notice, it doesn't matter whether n is even or odd. We still use the same formula, n plus 1 over 2. And if your n is odd, this becomes very straightforward to find the median. It's when n is even that you have to know what this means. It just means take the average of the two values that are closest to this. Okay. Usually the people that use the formula get it right more often than the people that cross things off. And this is kind of beyond the scope of this course, but it's possible, depending on what you do with your career, you might need to find the median of a data set that has millions of values in it. Chances are you're going to use a computer for that instead of doing it by hand, but can you imagine marking off two values in a row until you got to the middle? That would take forever. But with this formula, if it's in a spreadsheet, you can go to the row or the middle of the two rows that you're looking for right away. And that becomes much easier to calculate. It's a little more sophisticated doing it this way too. We're not in grade school anymore. Come on, let's go. We want to do things that look impressive, like use formulas. So, that is the median. Now, one of the things about the median that I do want to say here The median is an okay measure of center. It's fine. In fact, in some cases, and we'll talk about this in our next video, in some cases the median is going to be the way we want to measure the center of a data set. And that's because no matter whether it was 60 in the original or 62.5 when we took that 10 off, it's by definition in the middle of the data set. So it's a pretty good measure of center sometimes. Sometimes. But there are cases where we're going to want to use something else instead of the median. The other version, well, okay, so I do want to say, why is the median not necessarily amazing? It's because the median only uses the position of the data values in a data set, not the values themselves, except for the 1 or the 2 in the middle, right? To calculate the median of this data set, either the one we started with or when we took the 10 out, either way, when we were calculating the median, we did not care what the numbers were, except for the 1 or the 2 in the middle. It doesn't matter that this was 8,000. It doesn't matter that this was 10. We never used those numbers. If we want to find the middle of a data set, it's not as simple as just saying, there's the middle. We actually want to use as many of the values as possible so that we're actually using the data in the data set. And with the median, you're not really doing that. You're only looking at the values in the middle. In a perfect world, we would like to utilize all of these numbers in the calculation of the center of the data set. We want every data value to feel important and valued. And the median just doesn't care. It's taking all the numbers except for the ones in the middle and saying, don't care. So you're in the data set, whatever. We want every data value to be important. And that's where our third and final measure of center comes in. You might know what it is already, especially if you've already looked at the blank copy of the notes in Canvas. We're talking about the mean. Talking about the mean. Now, you probably already know how to calculate the mean of a data set, right? If you do, go ahead, pause the video for a second. Let's keep this first 10 in here. We want to preserve that 10. Oh, goodness gracious. I just made a dog's dinner out of this, haven't I? Let me put the 10 back. Boop. I want you to calculate the mean of this data set, if you know how. Come back when you've got it, we'll compare notes. And hopefully I remember to cut this part out because I haven't calculated the mean yet, and I need to take time to do that. Okay, so finding the mean of a data set is a two-step process. First step, add all of your data values together. So this is the formal mathematical notation for how to add up all the values of a data set. If you are intimidated by this, don't worry. This is all it means. This is the English version. This is the formal math version. Okay. This symbol here is a Greek letter. It's capital sigma. And we're taking xi, so like an I goes from 1 to n, so we're taking x1, x2, x3, which are the first, second, third, and so on values in the data set, up to n. So x1 through x9, and we're adding them up. That's all that means. Okay, so you get that sum. Step 2, divide by the sample size, which we're going to be consistent here. We're going to call the sample size n. So we're taking the sum of all the data values from 10 plus 10 all the way up to 8,000 and dividing by 9, since there are 9 values. So this is the formula for a sample mean, and this is how we denote it. So this is a sample mean. This is called X bar. We statisticians are a very creative people. It's because it's an X with a bar on it. It's called X bar, and that is how we denote a sample mean. X bar. And that's our formula. You probably already knew that. We're just putting the formal mathematics behind it and the real notation. So when we do that calculation, we get 944.4. Okay. So that's the formula for a sample mean. We are going to differentiate between taking the mean of a sample, which is X bar. We're pretending this is a sample because it is. There were more values. If we were going to calculate the mean of an entire population, remember that's all of the individuals that we're interested in, not just a sample of them, but everything. A population mean we don't call it X bar anymore if it's for a population. We actually call it this. This is the Greek letter mu, spelled mu in English, mu, and the calculation is still the same as this. We're going to add up all of the data values, but instead of dividing by the sample size, we're going to be dividing by the population size. Sample size is lowercase n, population size, capital N. So this is the population size. Okay. If the formula is the same, which it really is, why are we making a big deal about whether it's from a sample or a population? This is a question that will be answered in future statistics courses. We're not really going to touch that this semester, but it does make a difference because although this calculation is the same, there are other statistics that you'll calculate, including one in the next section that we'll talk about, where the calculation is different, whether it's a sample or a population. So that is something you have to keep in mind. If you're calculating these things for a data set, does this represent a sample or a population? And for your project, you're always going to be using the sample calculations. Okay, but I do want you to know that there are calculations for the population as well. So there's one more thing I want to say about the mean. Just one more thing. And that is, we made fun of the median earlier because it doesn't utilize the data values, just the position where they are. The mean does use all the data values. We had to use all of those numbers to find the mean. So that's good. We like that. We like the fact that it uses all the values. The mean uses all data values. But there's a but. There's always a but, right? What's wrong with the mean? Do you find anything strange about the fact that this was 944.4 for that data set in green? Is this the center of that data set? I mean, we took all the data values and divided by 9, but this is nowhere near the center of this data set. This seems really large. Why is this number so big? Because of that. This value is dominating all the rest. So although the mean uses all the data values, that can actually be a bad thing if you've got values that are really odd, either really big or if there were any that were super small. So the way we say that is, it is affected by outliers. Okay, so we like the fact that it uses all of the values except for when we've got some really strange numbers. Then it's like the outliers, that 8,000 is pulling the mean towards it and away from the center of the data set. So that's all we're going to talk about in this video. But just to give you a sneak preview, we've talked about 3 different measures of center here, and we are not caring about the mode. It's really about mean versus median. We're going to talk about when do you want to use the median for the measure of center of a data set versus when you want to use mean. There are certain times where one is better than the other. And I think we've kind of talked about that here already, but we're going to really make that clear going forward. So, for the next video, we'll talk about that, and I think we're good for this one. So, we'll see you in the next video. Keep working on that project.